Hello and welcome back everybody. This is Noah, and in this video we are going to look at an application of using GCFs. This is a now you try problem, so we're going to walk through its solution. If you haven't tried this on your own yet, please go ahead and pause this video and look through these instructions and work this out on your own. Once you've taken a chance to try and hash this out without help, then go ahead and unpause it and watch through this solution. Let's take a closer look. So in the previous lesson, not the previous video, but the completely previous lesson, we looked at how average revenue on an item that you're selling can be approximately modeled according to its price using a quadratic function. I'm not going to go back over that in this lesson. We're just going to remember that we had talked about that. Let's look back at that example specifically. So suppose a coffee shop is opening and the owner is determining a price point for a cup of coffee. From research, they determine that their average revenue per day will be approximated by R of P equals negative 120 P squared plus 750 P. We're going to start this out by finding the P-intercepts, the horizontal intercepts, by factoring out the greatest common factor and using the zero product principle. We will interpret these P-intercepts in context of the scenario. So I'm going to set the function R of P equal to negative 120 P squared plus 750 P equal to 0. So I have 0 equals negative 120 P squared plus 750 P. I'll then write 0 equals and factor the right side using a greatest common factor. So we can pull out a negative 10 for sure from both 120 and 750. And pull out a 10, and it looks like 3 goes into both of them also. So if I pulled out a 30 goes into 124 times, and 30 goes into 750. Let's think about that. 750 divided by 30 would equal 75 over 3 equals 25. So it goes in nicely there as well. So I'll factor out a negative 30, and I can also pull a P out of both. So we'll have negative 30P, open up parentheses, and then we'll have negative 30 goes into negative 120 4 times, and we'll still have a P left in that term. And then we'll have a minus, because we're having to factor that plus out as a negative. And we determined that 750 divided by 30 is going to be 25. And we've factored that P out, so no P's left over here. So this gives us that P equals 0, or 4P minus 25 equals 0. Get a little bit more space here. Always a little, oops. What's the word? I'm always a little hopeful that it won't take up that much room, but I want to make sure we've got room for everything. So the second one, I'll add the 25 to the right to get 4P equals 25, and then I'll divide by 4 to get P equals 25 over 4, and this is going to be 6.25. I'm writing it as a decimal. We're talking about money. This is a price point, so it kind of makes sense to write it in that manner. So these prices are where the revenue would be 0. If we interpret this, what this is saying is that by setting 0 to the, by setting if capital R equals 0, so the revenue is $0, then the price is either $0 or $6.25. You'd say this the other way might make a little more sense, but I'm just saying it that way because that's kind of how we solved it. We set the revenue to 0 first. So if the price of a cup of coffee is $0 or $6.25, then no revenue will be made. And that's not even profit. That's saying that we're not going to bring anything in. What happens is if the price is zero, we might sell a bunch of coffee, but we didn't collect any money, right? Because they're all $0. If it's $6.25, what's happening is that the price is so high that no one's willing to pay it. So we're not going to make any money because no one's going to pay $6.25 for a regular cup of coffee. At least not in the market where it stands today. All right, so let's look at part B. We want to find the vertical intercept and interpret it in context of the scenario. The vertical intercept is when the input equals 0, when p equals 0. So we'll say, what is r of 0? And this equals negative 120 times 0 squared plus 750 times 0, and everything zeroes out, so this just equals 0. And this is just saying if the price of a cup of coffee is $0, no revenue is collected. And we actually saw that in the previous one, right? So the vertical intercept and the first horizontal intercept are the same, right? We have an intercept at the origin, which is both a horizontal and vertical intercept. And we'll graph that here in a few minutes in part D. So next thing we want to do is find the vertex of the function. So the vertex has the x value of the vertex is going to be negative b over 2a. Let's write down that function again. We have r of p equals negative 120p squared plus 750p. So a equals negative 120, b equals 750. So the x value of the vertex is going to equal negative 750 over 2 times negative 120. We'll go ahead and simplify this down. This is going to be 750 over 240. That's 75 over 24. 3 goes into both of those. That's 25 over 8. And that will come down to $3 and 12.5 cents, or 3.125. Let's give myself a little bit more room. We still need the output of this. So if I say, what is r of 3.125, we will get negative 120 times 3.125 squared plus 750 times 3.125. Doing that by hand sounds just way more tedious than it would need to be. We'd have to get some multiplication using decimals going on. Let's just go ahead and use our handy calculator here. So our input is going to be negative 120 times 3.125 to the second, and then we'll go plus 750 times 3.1, whoops, back up, 0.125, and we get that this equals 1,171.875. That is a busy coffee shop if it's making that much money off of a cup of coffee. Probably not the most realistic model for this revenue, but it's going to give us at least a sense of how this might get used. So if we can interpret this, if the price of coffee is set to $3 and let's say $3.12.5, right? Then the revenue pulled in, this is before expenses, but the revenue pulled in would be $1,171.875. Obviously, we aren't going to do fractions of cents at a coffee shop. That's something that only gas stations pull off. So in practice, we would probably set the price to $3.12 or $3.13 to maximize this revenue. But we know in practice, if we're actually running a business, we'll probably just round that down to $3 and still acquire most of that revenue without inconveniencing people with a 12-cent price on top of the $3, which is kind of weird to do. You might bump it up to $3.25 to get that extra quarter. But yeah. All right, let's go ahead and graph this by hand, and we're going to discuss how to read it in context of the scenario. Let's do this off to the right here. Get my axes drawn. I know that I only really care about if the price is greater than 0 and when the revenue is greater than 0. We can't really lose revenue. We can lose money in general, but revenue is income. We're never going to have negative sales, right? We're going to have negative money on our expenses, but revenue isn't expenses. It's just the amount you're bringing in off of sales. There is a way to have negative revenue. If you have a day where you have a store and you've sold absolutely nothing, but you have had someone come in and make a return, then you have lost revenue. You have a negative revenue on that day. But let's not worry about that extreme scenario here. So I'll define my axes, P on the horizontal axis, R on the vertical axis, and then let's plot the horizontal intercepts, which occur at the origin, 0, 0 there. And then we know the other horizontal intercept happens at 6.25 from part A. So I'm going to try and figure out a good scale. Let's do, how far out do I have here? Let's go 1, 2, 3, 4, 5, 6. Is that what I want to do? Let's actually make this longer. So I can go by 4 so that we can see the quarters in there. So if I'm going by 4, so there's $1, oops, 1, 2, 3, 4, 5, and we want this to go out all the way to like 7. So 6, and then 7 would be there. So our next horizontal intercept would be at 6.25. Draw and label that 6.25, comma 0. And then at 3.125, we have a revenue maxed out at 1,171.875. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's put 1,000 here at 10. 1, 2, 3, 4, 5 500s here. So we have 3.125 and then 1,171. So that's up like in here, right? Here's 1,100 and then 1,150, and so halfway between that and the next line. So if I go straight up and I get my vertex right there at 3.125, comma 1,171.875. It's a bad idea to use commas in numbers inside of a point because then you have multiple commas and it gets pretty confusing there. So we're not going to do that. All right, so there's our vertex. I want that in red as part of our graph. And then we had We don't have any other points. Let's get just a couple more in here. Let's say what's going to happen if I did R of 2? If we have $2 here as the price point, we'd have negative 120 times 2 squared plus 750 times 2. I think I could do this by hand faster than with the calculator. This will be negative 120 times 4 plus 750 times 2 is 1500. Negative 120 times 4 is negative 480 plus 1500. And so if I subtract 480 there, I'll get $1,020. So at 2, we'll go up to 1,020. Just over the 1,000 mark. Do this in red. Let's note that it's going to have a mirror across 3.125 over at 4.25. Mirror 2 over 3.125 to, so that's 1.125. So I'll go up to 4.125 and then another 0.125 would be 4.25. So if I go 2 to 3.125 and then that same amount would bring us up to 4.25. So I'll have 4.25 and then I'm going straight up here to 1,020. So 4.25 comma 1,020 and 2 comma 1,020. All right, now we've got full 5 points. I think that'll just help us draw our parabola in a little bit nicer. To draw this, we're not going to draw negative revenue or negative price. It doesn't make any sense. If we had a negative price, that would be like paying people to take the coffee. I suppose you could do that. All right, and then it just says, discuss how we can read it in context. So if I was reading this, I would say, as the price goes up from $0 to $3 and $3.125, the revenue goes up to 1,171.875. Then, as the price passes $3.125, the revenue, fix that P, the revenue decreases until a price of $6.25 when the revenue is $0 again. All right. So there's us really trying to analyze this situation, getting a full graph, kind of understanding how that price point is going to affect our revenue so that we can make an informed decision on how we want to set the price point for our coffee. In practice, there are going to be other things that you take into consideration as far as the competition's prices and just understanding the market and your customer base and who you're trying to reach. But it's nice to have a mathematical analysis of what kind of things could happen for your income based on the price point that you set. And so this model is helping us make some sense of that. Note that the numbers for this revenue function are not necessarily realistic, and that a lot of things would go into finding these numbers based off of doing some research on what different coffee shops have for their revenue based on different price points and getting some data to model a quadratic function. That's something that you might see in a stats class to be able to come up with a function like this. There are some other ways of looking at this to come up with this quadratic function, but in practice we would probably want to look at some statistics. All right, that's everything for this video. Thanks so much for watching, everyone, and we will see you later. Take care now.